Welcome back. This session is about internetwork routing. So routing through an internetwork is similar to routing within a network, but a little bit complicated. Let us see an example. This is an example for an internetwork. So each node here is actually a network, an autonomous system, and two different autonomous systems are interconnected using a multi-protocol router or gateway. First step of routing, we have to convert this entire network into a graph representation, right? In the case of an internetwork, every router which is connected to a particular network can directly access all the routers connected to that network. That means here B can directly access A, C and D. So based on that, when we convert this network into a graph, this will be the graphical representation. Router A can access B, E and C. Like that, B can access A, C and D. So this will be the representation. And once the construction of the graph is over, a two-level routing algorithm can be used. As we have learned in the case of autonomous system, each autonomous system will have its own routing protocol. So the corresponding protocol, we can call it as interior gateway protocol within each network. And among these different network or among the different autonomous system, we have this exterior gateway protocol. Any non-routing algorithms such as distance vector, link state algorithms can be applied to set of multi-protocol routers. That is the exterior or inter-autonomous routing. Suppose the sender host reside in this network 1 and the destination host reside in this network 5. So usually that data packet starts its journey as a frame, right? Suppose this is an Ethernet. So this data packet starts as a Ethernet frame, and if the destination is in the same network, it will be traveled as a frame itself and will reach the destination within this network using intra-autonomous routing, using some protocol, that is interior gateway protocol, right? But here the destination is in some other network, so definitely it will be forwarded to the nearest multi-protocol router, right? Suppose this is the nearest router in our case, this is the destination, right? So that frame will be forwarded to this multi-protocol router. And from the data link layer of this router, it will reach the network layer. And as you know, all the multi-protocol routers run the inter-autonomous routing algorithm, right? To route packets among different networks. So here also the same happens. And consulting the routing table, it will find out the next multi-protocol router to be forwarded. Suppose from the routing table, it finds that F is the next router to be forwarded. So definitely that packet should be moved across this network 4, right? So if the network layer protocol of this network is same as that of the sender machine, that is the IP packet is now in this format, right? And this network also follows the same network layer format forwarded across this network to router F. Otherwise, that is network 4 is something else, say it is a WAN with a completely different network layer protocol. In that case, tunneling will be applied, right? Yeah, the IP packet from here will be encapsulated into the network layer packet of this particular network, and that will be forwarded to multi-protocol router F. And from there, the same procedure happens depending on the destination network type. This is how inter-network routing will proceed. Now, if we compare this inter-network routing with the intra-network routing, then one of the major differences is that inter-network routing may require crossing international boundaries. In such case, some rules or laws may come into play. Just for example, some countries have prohibitions in exporting personal data, right? And the second difference is in cost. In case of an intra-network routing, all the nodes in the network is running under the same management, right? So the cost will be the same for the entire network. Whereas in case of inter-network routing, different networks may be under different managements and one route may be less expensive than the other. So such criteria also should be considered while routing protocol is implemented. Quality of service is another factor which may differ for a different network in case of an inter-network routing. So that also should be considered while choosing a new route.